Hey guys, welcome back to another Leetcode problem solving tutorial, and in this tutorial I'm going to be showing you guys how we can find the maximum depth of a binary tree. So a binary tree is essentially this data structure. If you haven't met it before, it's implemented in TypeScript using this sort of class, and essentially for each root you're given a root, which is this, and it points to a left and right node. So you'll be given this root node and it points to 9 and 20, and then this 20 is going to point to 5 and 7, 15 and 7. So our job is to find the maximum depth of a binary tree. The maximum depth is essentially just, well, you can go here and then you can go this way to the left, and that's going to give you a depth of, it's going to give you a depth of 2 because you include this and this. Or you could go this way and then this way. That's going to give you a depth of 1, 2, 3. And also you could go this way, and this way, which is also going to give you a depth of 3. So in this case, the maximum depth is 3, which is how we get that. And the way we're going to implement this is similar to many other binary tree questions. It's just by using recursion. So, recursion. Well, let's draw out our tree. So, I'll draw out the tree 3, 9, 20, and I think it was 15, 7. Okay, so this is what our tree looks like right now. And the way we think about recursion is, remember, we implement our base cases at the top, but we do those later. The main case is the recursive case, and we assume function works. We just assume function works for items below, or I should say nodes below. So let's just assume that this max depth function just returns a max depth of any node, right? So that means, well, if we're at this node right now, then the max depth is just going to be, well, we want to return 1 plus the maximum of the max depth of the left node below and the right node below, because if this right node below has a greater maximum depth, then obviously, well, it's going to be a greater maximum depth for this one than here. So from here, this node has a maximum depth of 1, whereas this node has a maximum depth of 2. So we just want to return the maximum using math.max function of simply max depth root.left, and don't worry about this, we'll fix that later, or max depth root.right, like so. So that's what we're going to do. So we assume that this function is working for these root.left and root.right. So we get the maximum depth of each of these. Let's just take this right one. So the maximum depth of this is going to be, let's just call it maximum depth, is going to be 2, because we have this one and this one, or this one and this one, either of which, and that's going to return 2. So then the max depth for this one, well, we're just going to, it's obviously just going to be the maximum depth of this, 2 plus 1 to include for this node over here, which gives us md is equal to 3. And obviously we'd compare that with the md equal to 1 here. And this one's the bigger one, so we take this one. So pretty simple stuff, really. And now, so we've thought about our recursive case, but we need to think about the base cases now, where we return solid values. So here all we're doing is recalling the function again, but eventually we're going to have to return an actual value. And that value is simply just, so the base case would be, well, when we're at this 9 value here, we're going to call the root.left and root.right, but both of these point to none items. So what we're going to do is check if root is equal to null. And if this is the case, well, the maximum depth of a null item is obviously 0, because there's no items within it, right? Like if you're here, there's nothing underneath it. This doesn't even count as an item because it's null, so that's just going to be nothing. So max depth here is equal to 0. So this would return 0, and then, well, if you put it here as well, this is left and right, but they're both equal to 0. So the max of this is going to be 0. So this gets returned as 0, and then we get 1 here, and that's basically how this function works, because then same thing happens here. we go here, MD is equal to, well, 0 plus 1, which is 1. MD is also 1 over here, so then we get MD is 2 there, and then we get MD is 3 there. So that's basically how this recursive function works, nice and simply. And yeah, that's essentially all we do, because now if we were to call max depth given the root of a tree, well, that's like given in this root, and then it's going to just recurse all the way down. So yeah, that's this function complete. Really simple actually when you look at it, but let's see what we get. Okay, so we actually get some pretty good runtime for once. Beats 88%, so not in the 90th percentile, but you'll see most people are essentially doing the same thing. Like, this is exactly the same, and it is in the 90th percentile, so yeah. Let's have a look at some other ones. Oh, we missed it. And yeah, this is also exactly the same. So it's essentially everyone's using the same algorithm, just adding 1 plus the max depth of what's below it. And simple algorithm, but it's really useful and it's incredibly important for other algorithms regarding binary trees. So make sure you fully understand this one. Hopefully I explained it well. Thanks for watching, and I'll see you guys in a future tutorial. Bye.